We are discussing the various ways of expressing concentration, and the last one is molality. So, molality and molarity sound quite similar, but they are a lot different from each other. So, molarity is the number of moles of the solute. I'm going to write that here. So, molarity is the number of moles of the solute divided by the volume of the solution in liters. So, that is molarity. Molality, on the other hand, is denoted as a small m. And this is the number of moles of the solute in 1 kg of or per kg of the solvent. So one again important distinction is the fact that one, here you have per kg, as in this is going to be the mass, whereas this is the volume. The other one is the fact that we are saying solvent and not the solution. In case of molarity, we spoke about the volume of the solution, not just the volume of the solvent, whereas in case of molality, it's just the mass of the solvent. So the formula is obviously going to be molality equals to number of moles of solute divided by the mass of solvent in kilograms. And it can also be written as number of moles of the solute divided by mass of the solvent in grams into 1000. It's similar to what we saw for molarity, right? And the units is going to be moles per kilogram. So moles, because the number of moles is mole divided by kg, which is moles per kg. That's the unit. Now, what does all of this mean? It means that, let's say, for example, we have 1 molal, or it can also be written as 1.00 moles per kilogram of KCl. This means that you have 1 mole of KCl in 1 kilogram of water. That's what this particular thing means. So that's molality. Remember, if you understand molarity, it's almost similar, but not the same. It's not the same because in case of molarity, we are considering the volume and we are considering the volume of the solution. Whereas in case of molality, we are considering the mass and the mass of the solvent and not the solution as a whole. Here we've been given the question 2.3. Calculate the molality of 2.5 grams of ethanoic acid in 75 grams of benzene. So we have to calculate the molality, and we've been given mass of ethanoic acid, that's CH3COOH, that's equal to 2.5 grams. And we've also been given mass of benzene. So benzene, as you know, is the solvent, right? So benzene is the solvent, and we've been given the mass of the solvent in grams. It's fine, we can just multiply it with 1000. And we've also been given the mass of the solute. So we can calculate the number of moles of the solute. So number of moles of CH3COOH will be equal to the mass, that is 2.5 grams, divided by the molar mass. So the molar mass of acetic acid equals to CH3. So I'm going to write this formula again as C2H3 plus 1 4O2, right? C2H4O2. So 12 into 2 plus 4 into 1 plus 16 into 2. And this is equal to 60 grams per mole. So this is the molar mass of acetic acid or ethanoic acid. So the number of moles of ethanoic acid is going to be 2.5 grams divided by 60 grams per mole. And cancel and simplify, and we get the number of moles of acetic acid is equal to 0.0417 moles. So we have the number of moles, we have the mass of the solvent, and we can just substitute. You can convert the grams to kilograms, but I prefer just putting it in the formula and finally getting the answer. So the molality, I'm just going to write the word. Molality of CH3COOH will be equal to the number of moles of CH3COOH divided by the mass of benzene, C6H6. So 0.0417 moles by, again, since we are multiplying it with 1000, we'll be getting it finally in kilograms, moles per kilogram. So I'm just going to say into 1000, dividing it by 75, and this is going to be moles per kg. And when this gets simplified, we get the molality as 0.556 moles per kg. And it's up to you. You can, whatever you find easy. If you find it easy to get the weight, or rather mass, in kilograms and then substitute it in this equation, it's fine. But honestly, this is a little better because when you have zeros, it's easier to use it in an equation, I guess. So with that, we're done with molality. Number of moles of the solute in 1 kilo of, or per kg of the solvent is molality, and its unit is moles per kilogram. It's denoted as a smaller m. It's different from molarity. Don't get confused between the both. And that's it. And we also solved an example problem related to molality. With that, we're done with the various ways of expressing concentration. One thing I'd like to point out is the fact that out of all the things that we've learned, mass percentage, parts per million, and mole fraction and molality, all of these are independent of the temperature. Now think about it. When you have water, okay, and when you heat the water, there is obviously going to be change in volume. That is what you learned in class 11 again. But at room temperature and at atmospheric conditions, you have a particular volume of water, and when you heat it, there is going to be a change in water. So what I'm trying to say is the volume changes with change in temperature, and because of that, our various especially molarity itself is dependent on temperature. So molarity of a solution at, let's say, 20 degrees Celsius will be different from the molarity of that solution at 50 degrees Celsius. So there is a change because there is a change in the volume itself. With that, we're done with the various methods of expressing concentration. I hope you understood all of this. Just go through all the formulae, and if you find it easy, make notes and just write have a paper which has all the formulae related to this, and remember to write down the formulae related to mole fraction and number of moles as well. That's easy because we use the number of moles a lot. And in the next video, we'll be solving the in-text questions.